All right. Advent.co 2018 Day 2 Inventory Management System. Oh, that sounds wonderful. You stop falling through time. Okay, so you stopped falling. Catch your breath and check the screen on the device. Destination reach current year 1518. Right, because we were starting in 2018, so we've gone 500 years in the past. North Pole Utility Closet 83N10. So now we have to find anomalies. Right, the stars. We've gotten 2 stars so far. Outside the utility closet, you hear footsteps and a voice. I'm not sure either, but how many people have chimneys? Maybe you could sneak in that way. Oh, it says, okay, the beginning of the chimney thing. What do we need to do? I'm not going to read the whole thing. What is the checksum for your list of box IDs? That's what we're trying to figure out. And how do you calculate a checksum? We're trying to have fabric to fill several boxes. So we're trying to find 2 similar box IDs. You sneak into the warehouse and use your fancy wrist device to quickly scan every box and produce a list of the likely candidates to your puzzle input. All right, so let's take a look at the puzzle input. Get input 2018, day 2. Wow. And there's 250 lines. They all look very similar. JWZIZP at the end here, mostly. And a lot of them start with OML. This one starts FML. That's funny. Okay. To make sure you didn't miss any, you scan the likely candidate boxes again, counting the number that have an ID containing exactly 2 of any letter, and then separately counting those with exactly 3 of any letter. You can multiply those 2 counts together and get a rudimentary checksum and compare it to what your device predicts. Okay. And these are all lowercase letters, so we can just create an array of 26. So let's figure this out. I think the way I got to remember how to start off, right? So I create a new one of these, and then I insert a new day here, right? And then we got unresolved module, so we create it. We jump to it. We do AOC, the utilisnip for it, 2018, oops, O2. So 28, change all the 20s to 18s. And then change the O2 down here to that. And now I've saved everything and it blew up because I forgot to do this. It's a lot of work just to get something running. Okay, so now if I say bacon and hit run, it runs day 2. Perfect. Let's jump to it. And what are we going to need? We're going to need the list of all these things here, right, as strings. So we have the, and what are we calling these? Box IDs? Box ID. Vec string, right? And we can just save that here. Self box ID is equal to AOC lib, read lines, 2018, input 2018 o2.text, right? And then here we'll just print the length, make sure we get 250 of them, box ID len, right? 250, all right. So now we need to loop over each one of them. That's going to be part 1, and then count how many have exactly 2 of any character, of any letter, and exactly 3 of any letter. And it looked like the letters, if I go to the input here, right? It's all lowercase ASCII, right? So we can just create an array for box. Oh, I can't use box. For ID in self box IDs. Again, what we can do is we can just create a brand new vec, let counts equals mut counts. Right, we can just say usize semi 26. Right? And now counts is an array of 26 zeros. And now we can loop over each one of the characters in the string. Right? And we can just increment that count. Count of C as U8 minus B of A plus equals 1. Right? Does that work? Counts. Oh, as usize. There. And now that we've counted them all up, after we've done with the count, we can say, do we have a 2? And do we have a 3? So let mut count of 2s and count of 3s, right? If counts, can you do this? Find 2? Count of 2s plus equals 1. Can we do that? There's no method named find in arrays. Masek says, I wonder if you can use SIMD operations to check if count has an element equal to 2 or 3 in one go. Probably. I've never tried SIMD. Expected FN mute ampersand usize. Isn't it doesn't, oh, it still doesn't like it though. Oh, because find is expecting a closure. Right. There's got to be something else. There's got to be some other Rust iter find. Oh, is it vec that has find x equals 2? I think that's what I was looking for, right? Expected a block. Oh, I forgot the open brace. This is an option? Oh no, it's double amp. Expected bool found option usize. Oh, is sum. Well, then you know what we can do. Counts probably has a contains method. Even though counts is a slice, we can see that. We can try it. Sorry. Counts contains 2. Consider borrowing there. Oh, okay. That's much better. And because this returns a Boolean, right? Yeah, it returns a Boolean. We can do this. Count of 2s plus equals as I32, right? And we can do the same thing for 3s. And then what was the thing? We wanted to multiply them together? Yeah, multiply them together. $71.05. Should we try it? Hey, that's the right answer. All right. Can we clean this up at all? What can we do in terms of making this more functional? I don't see it any cleaner to make it functional. You know, we could throw in a for each, but that's not. Yeah, this is good enough. Git status, git commit -am 2018 day 2 part 1. All right, so what could part 2 be? Interesting. Why didn't that? Oh, because I forgot to add it. with the code this time. Right? Last backseat of the day for me. Oh, did I not put the backseat tag on here? I like backseating, so please feel free. Try to get Bacon in Clippy mode, because I'm pretty sure Clippy would have told you about contains. Oh, yeah. So I have it just running, but yeah, Clippy will... Oh, look at that. Clippy's complaining about 2016 now. Wonderful. All right, let me finish 20... So obviously I have to turn this off now because it's going to be distracting. But let me finish day 2, and then we'll go back and clean up day 1. I mean the Clippy warnings. Bum. All right, so that was day 2 part 1. Let's try day 2 part 2. Confident that your list of box IDs is complete, you're ready to find the boxes full of prototype fabric. Right, the elves up above were trying to find the prototype fabric. Boxes will have IDs which differ by exactly one character at the same position in both strings. For example, given the following box IDs, the IDs ABCD and AXCYE are close, but they differ by 2 characters, the second and fourth. However, FGHIJ and FGUIJ differ by exactly 1. What letters are common between the 2 correct box IDs? In the example above, this is found by removing the differing character from either ID, producing FGIJ. All right, so we're looking for a string. I'm trying to think. I don't think I can think of anything fancy here other than just looping over all of them and comparing every pair, which isn't exciting, but it'll work. For I in 0 ... self box ID len -1. For j in I plus 1 ... self box ID len. All right, and we'll just compare I and j. It might be interesting to make a little trait. They have to be in the same position. So we're just comparing positions of... I was thinking it would be fun to do like a little trait, self box ID of I compared to self box ID of j, right? Equals 1. But that's just going to be... Let's call that Plan B. Plan A is we're just going to compare them, right? So we can say for self box ID I chars zip self box ID j chars, right? And we'll see if there's exactly one character that are... okay, so now we're just going to compare them. Let's see. How do we... Can I destructure them as a tuple? I can. Look at that. So we could just have a let mut count equals 0, count plus equals A equals B as I32, and then if count is 1, we found our answer. If count equals 1, then we need to split and rejoin. Well, let's just print these out. Print ln first is equal to this one, self box ID I, and then we can just look to see if we found it correctly. Second is equal to this one, right? And then I'll keep looping to see, just to see if maybe we'll get multiple. We shouldn't. Didn't like that. Why? Oh, because I never returned the output. Create output X. All right, so I didn't see any where it differed by single. Let's print out all the counts. It's saying that there's 20 match everywhere. I'm looking to see. I'm counting the common characters. Right. Oh, you're right. I should be counting where they differ. And then let me get rid of this because it generates a lot of output. Yeah, okay, so it did find one. Thank you. Thank you, Mousix. This is why I need backseating. Otherwise, I mess up badly. All right, so now what we need to do is figure out which one it is. I guess we could just... Where does it differ? Right here, W and L. We can save the location. What would be the easiest one would be to just save the character, right? Let mut char equals A. I can't call it char. I'll call it diff equals A. And then we can say if A is not equal to B, count plus equals 1, and we can just save the diff character on, and it doesn't matter which one. Right? This will still give us the same answer. Oh, I guess we could do this. No, I gotta all right. It's true, this assignment. Well, okay, so here we go. So if the count is 1, then we're going to find it in A, right? We're going to say self let position is equal to self box ID of I dot. This is a string, right? So in a string, we should have like a find. It gives us a, yeah. Returns the byte index of the first character in the string slice that matches the pattern. Okay, so we can just say find diff, right? And that should give us the position here. And then we can just split the string at that location. Oops. Okay, it's at 21. So I assume this is 21. I have no idea. We'll find out. So unwrap. We'll do that. And then what we'll do is we take the first 20. Can I do that with a string? Rust string split. Right? I can say split at. String. Right? Split off. I thought I could do a split at. Maybe that's in the, yeah, here it is. It's in the slice. All right, so we can just split there. So we can just say front returns two strings, front back equals self box ID I dot split at pause, And then we can just put those here, front and back, right? Right, and the W is what we want to remove. Oh, even better, string remove. Thank you, Mouse-X. So we have the position, we can just remove that character directly. Let's see. It's not in the slice, it's in the string. And that's the index. Perfect. And it returns the character that got removed. So we just need to clone, right? We need a clone of this string. And does this have a name? Let's just call it common. Self box ID of i.clone, common, remove, pause, and then return crate output common. No answer found. All right. So this should be the answer. I don't see the W in there, so that's a good sign. Hey, that's the right answer. All right. And right, so this was going to be this part of it. But we got this, right? This seems to work. It's doing extra work, right? Because if A is not equal to B and count is already 1, then we can go to the next pair, right? Going to do this. We'll take next pair. If count is greater than 0, continue next pair. I mean, that's not, I mean, the number of strings we're dealing with is not a big deal. We have 5 here for 5 milliseconds. If I don't have this in there, what happens? It takes 15 milliseconds. Right? I'm hitting run over and over and over again. We have 15 or 16. If I put this back in, we're down to 5. So there's a little bit of savings, right? It takes a third the amount of speed to just find it, but I'm okay with this. Either way, it's fine, right? Yeah, there's nothing else to do. Git status, git commit -am 2018 day 2 part 2. Should we try part 3? Day 3? Why not?